Hello, my name is Dr. Dan Wedding, and this is DrWedding, VB12, Subroutines and Functions. Subroutines are just code that can be reused. The code is put in its own section that can be called from any place in the project. The advantages of using subroutines are they are written and debugged once. If a change is needed, it is only changed in one place, even if it is used throughout the code. The overall length of the program is shorter. You can choose the name of the subroutine, and it can help others understand your code. Subroutines are very easy to create in VB. Subroutines start with the word sub. Next, you can pick any name for your subroutine, such as my first sub. The name is followed by the parameter list. This is a list of variables that will be handed off to the subroutine so it can perform whatever task it needs to do. There are three ways values can be passed to the subroutine: by using a global variable, ByRef, and ByVal. Global variables do not need to be passed to the subroutine. ByRef means you're going to pass the actual variable down to the subroutine. If you make a change to the variable in the subroutine, it will be updated everywhere else. ByVal means you're going to pass a copy of the variable down to the subroutine. If you make a change to the variable in the subroutine, it will not be updated anywhere else. Lastly, you end the subroutine with endSub. Assume you need to clear 3 text boxes on a form and set 2 global variables back to their default values of 1 and 100. The code to perform this task is shown below. If the code is used multiple times, you have a choice. You can copy and paste the code multiple times, or you can put it in a subroutine. A major advantage of a subroutine is it makes updates easier. If you need to make a change to the code, it can be done easily in a subroutine. If it is copied and pasted all over the program, you are forced to start hunting throughout the code for every place the code exists to make the changes. If you use a few lines of code more than one time, you might want to consider moving them into a subroutine. The previous 5 lines of code can easily be moved into a subroutine. As stated earlier, start with sub, add a name, add the parameters that need to be passed to the subroutine, and end it with endSub. The subroutine that would be generated is shown below. Because int Bill and int Ted are global, the parameter list is empty. But if these variables were local, the first line would be different, and it is shown below. To make the subroutine run, you just have to call the subroutine by name. Many people say they call the subroutine because the command that would cause the subroutine to run was call. Call is optional now. To call the subroutine clear my form, the command would be call clear my form, or more simply, clear my form. Functions are pieces of code that perform a custom math equation. When you think of a function, you should think of something like sine, cosine, tangent, and powers. When you use sine in an equation, you actually use the function name and pass it a value. Sine takes the value, performs some math function using the supplied information, and returns the answer. For example, if you need to use some equation multiple times throughout your program, such as the one below, you will create a custom math function, and it can be inserted directly into an equation and used throughout the program. Functions are very easy to create in VB. Functions start with public function. Next, you can pick any name for your function, such as my calculation. The name is followed by the parameter list. This is a list of variables that will be handed off to the function so it can perform whatever task it needs to do. Just like when you're writing a subroutine, there are three ways values can be passed to the function: by using a global variable, ByRef, and ByVal. Global variables do not need to be passed to the function. ByRef means you're going to pass the actual value down to the function. If you make a change to the variable in the function, it will be updated everywhere else. ByVal means you're going to pass a copy of the variable to the function. If you make a change to the variable in the function, it will not be updated anywhere else. The line is then ended with as some variable type. This lets the function know what type of variable needs to be returned to the equation that is using it. Inside the function name is used like a variable. It is set equal to an equation and is assigned the answer. An example is shown below. Lastly, you end the function with end function. An example of a function to find the area of a circle when it is given the radius is shown below. Things to be aware of in this function. The parameter list includes one variable named radius. The ByVal in front of the variable name creates the variable just like a dim or friend statement. Because this value is being passed to the function using ByVal, it is only a copy of the value. ByRef would hand the original value over to the function. The function command has a as double at the end, so the function will return a double. The values in the parameter list are used in the equation. The equation is set equal to the function name. Once you have written the function, you can use it as many times as you want. You can also use it in an equation. An example of using area circle is shown below. The best way to learn how to write and use a subroutine and a function is through an example. I have opened up a new project named VB12 and generated a form. This form has one button and 4 labels on it. I'm going to write a program. When I press the button, it will read in 3 values and write them to value 1, value 2, and value 3. Then it will average the 3 values together and write the answer in average. These labels have text in them now, so I can see where they are on the form. But when the program runs, I want them to be blank. The first thing I'm going to do is clear value 1, value 2, value 3, and average in form load. I'm going to need to generate a variable for value 1, value 2, value 3, and average. First, we're going to have to read in a value into DBL v1. As before, we'll put this into a try-catch. Because we don't have any text boxes on the form, we're going to use an input box. I'm also going to add a message box as an error message in the catch. The try-catch will prevent the program from crashing if somebody enters a character for the double. However, it won't stop someone from entering a number outside the desired range of 0 to 100. To take care of that, I'm going to put the try-catch inside of a do-while loop. If somebody enters in an invalid value and the try-catch gets tripped, I want to make sure that the do loop runs again. So I'm going to assign a value to double v1 that will assure me that the loop will run again. after I read in a valid value, I'm going to write it to the label on the screen. Let's run this program and see what happens. When I press the button, the input box comes up. First, I'm going to test an invalid value. And the try-catch works. The do while also works because it's not letting me go forward until I give a valid value. Let's test a negative value. And now a number that's too large. Finally, we're going to enter a valid value. The value shows up on the form. Because we're reading in 3 values, I could copy this section of code 3 times. However, I'm going to move it into a subroutine and use it 3 times. I've moved the code section into a subroutine called read double. I created the subroutine by typing the word sub and giving it a name and ending it with end sub. Currently, there are errors in this section of code. The reason is this section of code doesn't know what these variables are. So what we're going to need to do is create some variables. There are 2 ways you can create a variable. The first way is the way you already know, by using dim or friend inside the subroutine. And this would just create some local variables. The other way is more important. We're going to declare variables between the parentheses. When the variables are declared here, the information can be passed back and forth. The 2 ways you can declare a variable is ByRef and ByVal. The first variable we're going to declare is going to be ByRef, because we want this variable to be updated in this subroutine. Next, we're going to give it a variable name. I'm going to substitute read-in value for dbl_v1. In order for us to use this subroutine, we'll have to call it. We call it by using the subroutine name, and then we put the information we wish to pass down between the parentheses inside the parameter list. When the program runs, dbl_v1 will be passed down and renamed read-in value. You may be wondering why the variable name has changed. There's no really good way to make the variable in the call match the variable in the subroutine. That's because the subroutine is going to be used multiple times. If it was only used 1 time, you wouldn't use a subroutine. For example, I'm going to end up calling this subroutine 3 times, and I'm going to pass it double v1 the first time, double v2 the second time, and double v3 the third time. So every time the subroutine is called, a different piece of information is going down. There really is no way to make them match. Therefore, it's customary to make a generic name inside the subroutine. You also might be wondering, how is ByRef creating a variable? And what type of variable is it declaring? ByRef and ByVal is a special way a subroutine can create a variable. It's not only creating a variable, but it's also looking at the information that is being passed, and it will declare the variable to match it. And because we're using ByRef, at the end of the subroutine, read-in value is returned back up to the call statement, and double v1 is updated. It will contain the information that was in read-in value in the subroutine. I can demonstrate this with a message box. By adding a message box that's going to display double v1, we can see that it's being updated by the subroutine. And the only reason it's being updated by the subroutine was because the variable was declared ByRef. Let's run this program and see what happens. When I press the button, the input box in the subroutine shows up. I'm going to type in a number, and press OK. The information will be put on the form in the label, and we can see in the message box that the information is inside the variable v1. Now I'm going to change the ByRef to ByVal. By changing the ByRef to ByVal, the value in the call statement will not be updated. Let's run the program and see what happens. We press the button, the input box shows up, we type in a number, and hit OK. The label is updated because the update is happening inside the subroutine. However, the information is not being returned to the call statement. So v1 is still 0. That's the main difference between ByRef and ByVal. ByRef will update the value in the call statement. ByVal will not. I have a memory trick to keep this straight. The V in val to me looks like an arrowhead that's pointing down. This reminds me that the value is only going to travel in one direction, down. Now I'm going to change the ByVal back to ByRef. Subroutines are useful when they're used multiple times. So let's pass v2 and v3 down to the subroutine. I've now added these 4 lines of code. I'll call the subroutine and then print out the value that was returned from the subroutine in a message box. I'll do this 3 times in a row. This will demonstrate that the subroutine can be called multiple times and it will update the variables in the call statement. Let's run the program. Press the button, enter a value, and you can see that v1 is now 96.3. We've called the subroutine a second time, and v2 has now been updated. We'll call it a third time, and now v3 has been updated. You'll notice that the subroutine is always writing to label v1. We want v1 to be on label v1. We want v2 to be on label v2, and we want v3 to be on label v3. In order for us to do that, the subroutine needs to be updated down here. This is very simple. All we need to do is add more information to the parameter list. So we'll go up to v1, and we'll want this one to be printed to label v1. We'll want this piece of information to be written to label v2, and we'll want this piece of information written to label v3. If I'm passing 2 parameters in the call statement, the subroutine needs to receive 2 parameters. So I'm going to add a second value to the parameter list. In this example, I'm going to use ByVal. However, I'm passing a label, and that's an object. So in this instance, it doesn't matter if I use ByRef or ByVal. Objects are global, and any subroutine can update them. Now we have to give this a variable name, and we'll call it print label. Therefore, if we change this to print label, the first call will print to label 1, the second call will print to label 2, and the third call will print to label 3. I'm going to comment out the message box calls so we can focus in on the label updates. When the program runs, the first piece of information will go on the first label. The second piece of information will go on the second label. And the third piece of information will go on the third label. I'm going to make a few more changes to this subroutine. For example, the input box always reads enter value 1, but I want this to say enter value 1, enter value 2, and enter value 3. Because something is changing in the subroutine, I'm going to have to pass it this piece of information. So that's very easy to do. I'm just going to add another value to the parameter list. This time I'm going to actually add an integer value of 1. And I'm going to add a 2. And I'm going to add a 3. Because there are 3 parameters in the call statement, I have to have 3 parameters in the subroutine. So I'll just come down here, comma, ByVal, and then I need an integer name. I'll call this one count. Then I remove the 1 in the text string and then append count to it. Now the value at the end of the call statement will appear at the top of the input box. I'm going to clean this up a little bit more and remove the message boxes. I also want to clear the labels every time the button is pressed. I don't want to see the old information when I'm entering the new information because it can get confusing. I already have 4 lines of text which clear the labels. I could just copy these 4 lines and put them at the top of the subroutine for the button click. However, this is a lecture on subroutines, so why don't we make those 4 lines their own subroutine? All I need to do is type sub clear labels. Because this subroutine doesn't need anything given to it to complete its task, the parameter list is blank. Now I'm going to move these 4 lines into the subroutine. And I'm going to call this subroutine in form load. You'll notice the parentheses are still there for the parameter list, even though the parameter list is empty. That's required. Now I can copy this call and add it to the top of my button click. This way, every time I press the button, all the labels are clear before I enter new information. Let's run this program and verify both subroutines are working. The clear label subroutine is working because the labels are blank when the form loads. Let's run the program, and we can see that the read double subroutine is working. Let's type in a few numbers. And we can see that the labels are correctly recording the inputted numbers. And when we press the button a second time, the labels are cleared. Now we're going to write a function that will calculate the average of the 3 values. I'm going to go to the top of the program and add some space so I can start typing. First, we're going to tell the computer program that this is a public function, meaning anyone can use it. Then we're going to tell it it's a function. Next, we're going to give it a name, and we'll call this one average3. Now, average3 needs to be passed 3 values. So we can send them by ref or ByVal. It doesn't really matter because we're not going to be changing the 3 values we're passing it. We're going to be using them, but not changing them. So I'll just use ByVal on all 3. ByVal 1, ByVal 2, ByVal 3. Next, we have to tell the computer program what type of variable is going to be returned from this function. This is going to be returning a double. To write the function, we use the name of the function inside of the function. This is a little different than what we've done before. And this is going to be equal to 1 plus 2 plus 3, and then we're going to divide that by 3. To use the function, we'll go down to the button press, and we'll say dbl_av is going to equal the function av3 when av3 is given dblv1, dblv2, and dblv3. Lastly, we'll print this to the label. Now before I run this program, you can see how using functions and subroutines will make the program much easier to read. The button press is clear the labels, read the double, read the double, read the double, get the average of the 3, then print the information out to the text box. Let's test this program using the function. We press the button, we enter the first digit, and we enter the second digit, and we enter the third digit. When you run your program, you can start to see that there might be a problem. As you can see, we have a repeating decimal. The easiest way to fix this is to format the output. So let's go back to the program and format this output to 2 decimal places. And we'll try again. We enter the first digit, and we enter the second digit, and we enter the third digit. I've straightened up the program and added some comments. Please feel free to pause the video and read the comments. I hope this video has explained to you how to create and use subroutines and functions. I also hope that you understand the advantage of using a subroutine. In this example, read double did all the error checking and filtered the data. This program was written 1 time. However, it was called 3 times in button average. If in the future any changes needed to be made to this read, we would only need to update the subroutine and not update it 3 times in a row if it were copy and pasted. In review, subroutines are just code that can be reused. The code is put in its own section that can be called from any place in the project. The advantages of using subroutines are they are written and debugged once. If a change is needed, it is only changed in one place, even if it is used throughout the code. The overall length of the program is shorter. And you can choose the name of the subroutine, and it can help others understand your code. If you use a few lines of code more than 1 time, you might want to consider moving them into a subroutine. A subroutine starts with sub, followed by a name, and followed by the parameters inside a set of parentheses. The parameters can be passed using a global variable, ByRef, and ByVal. The code is next. Finally, it ends with endsub. An example of a subroutine to read in a double variable in the range of -100 to 100, along with error checking, is shown below. To make the subroutine run, you just have to call the subroutine by name. The number of parameters in the call must match the number of parameters in the subroutine. Two examples of calling the previous subroutine are shown below. Functions are pieces of code that perform a custom math equation. When you think of a function, you should think of something like sine, cosine, tangent, and powers. Functions start with public function. Next, you pick the name of your function, such as area triangle. The name is followed by the parameter list. This is a list of variables that need to be handed off to the function so it can perform whatever task it needs to do. There are three ways that values can be passed to the function: by using a global variable, ByRef, and ByVal. The line is then ended with as some variable type. This lets the function know what type of variable needs to be returned to the equation that is using it. Inside the function name is used like a variable. It is set equal to the equation and is assigned the answer. Lastly, you end the function with end function. An example of a function that is passed the base and height of a triangle and returns the area of the triangle is shown below. When using a function, the number of parameters in the call and the function must match. Four examples of using the area triangle function are shown below. If you find these videos useful, please like and subscribe. It is the only way I can continue to make these videos.